Welcome back to AI.Code.Cast, your daily dose of coding challenges. Today we're doing a deep dive into merge intervals. It's a problem that you see a lot in technical interviews. It sounds pretty simple when you first hear it, right? You have a bunch of intervals and things like meeting times, and you just need to combine the ones that overlap.
It really is kind of like tidying up a messy calendar, except instead of appointments, we're dealing with data. And you'll see that the logic behind this, it's not just for coding. I mean, you see this in project management, resource allocation, even when you analyze genetic data.
Okay, so before we get to the really clever algorithms, let's just make sure that we're all understanding the problem the same way. So think about a day that's full of meetings, right? You have one meeting from 1 to 3, another from 2 to 6, one more from 8 to 10, and then one last one from 3 to 5. So how would we take these overlapping meetings and merge them into a schedule that makes more sense?
Yeah, well, I think the most straightforward way to do it is what we call brute force, right? So you compare every interval with every other interval, and if they overlap, you merge them.
That sounds like, it sounds like checking every single drawer in your house to find your keys.
Yeah.
It might work eventually, but it's going to take forever if you have a ton of drawers. Or in our case, a ton of meetings. There's got to be a smarter way around.
Oh, for sure. The brute force method, it's easy to grasp, but it can get super slow as the number of intervals grows. Think about it, right. If you have just 10 meetings, you'd need to make almost 50 comparisons.
Sure.
But with 100 meetings, I mean, you're looking at almost 5,000 comparisons. That's why we really need algorithms that are more efficient.
All right, so what's a more elegant way to handle this? Got any hints you can toss our way to point us toward a better solution?
Well, let's think about how we could organize those intervals to make merging them a little easier. What if we could arrange them in a way where all the overlapping intervals end up next to each other?
Ooh, that's an interesting thought. Arranging them. Kind of like putting all the books by the same author together on a bookshelf so we could group all the overlapping meetings, then merging them would be a lot simpler.
Exactly. And one way to do that grouping is to sort those intervals. So if we sort them by their start times, any overlaps are just automatically going to be right next to each other in the list.
Okay, that's pretty clever. Sorting seems like a really powerful tool for this problem. So once we've got our intervals all sorted, how do we actually go about merging them?
Well, picture yourself going through this sorted list of meetings, right? One by one. You've got the current meeting that you're looking at and then the meeting before it. How would you decide if you should merge them or not?
Okay, I think I'd check if the current meeting starts before the previous meeting ends. And if it does, bam, they overlap so we can merge them.
You got it. And then we just adjust the end time of that merged meeting so it includes both of the original intervals. Now, if they don't overlap, we just take that previous meeting, add it to our final schedule, and then we move on to the next one.
So we're basically going through that sorted list, merging whenever we find overlaps, and adding the non-overlapping meetings to our schedule. That sounds a lot more efficient than the brute force method.
Oh, it definitely is. It's what we call the sort and merge approach. It's really popular because it's so simple and fast. But there is another really cool approach that involves using a graph to visualize the relationships between all of the intervals.
A graph. Okay, now I'm really intrigued. How would we use a graph to represent something like meeting times?
So think of each meeting as like a point on the graph, what we call a node. You've got your 1 to 3 meeting, your 2 to 6 meeting, and so on, all represented by these nodes. Now, for the fun part, we draw lines, what we call edges, between any two nodes if the meetings represented by those nodes overlap.
Okay, so since the 1 to 3 meeting overlaps with the 2 to 6 meeting, we would draw a line between those two nodes, right?
Precisely. And because the 2 to 6 meeting also overlaps with the 3 to 5 meeting, those nodes also get connected. What you start to see are these clusters forming, groups of nodes all linked together by those overlaps.
Okay, I think I'm starting to see. Those clusters are what you call connected components earlier.
They are really the key to this whole approach. They represent those groups of meetings that we ultimately want to merge together.
Okay, this is starting to make more sense.
Yeah.
So instead of comparing every meeting to every other meeting, we're essentially just looking for those clusters of connected meetings on our graph. And each cluster is basically one big merged meeting.
Exactly. It's like a visual shortcut to figure out which ones to merge. Now, remember how I mentioned that we could use search algorithms like depth-first search to find those connected components?
Yeah, the maze exploration algorithm. But you also said we don't actually have to code it from scratch, which is definitely a relief. So how do we use those pre-built search functions to actually help us with this merging problem?
Well, it all comes down to how we represent the graph in our code. So we use something called an adjacency list, which might sound kind of intimidating, but it's really just a list that tells us which nodes are connected to which.
Okay, so it's basically like a contact list for our meetings.
Yeah.
Each meeting has a list of all the other meetings it overlaps with.
Exactly. It's like saying meeting A is friends with meeting B and meeting C. And once we have that adjacency list, we can just feed it to our depth first search function.
And that depth-first search will just go through that contact list and find all the connected groups of meetings for us. So let's say depth-first search has done its job. It's given us all those connected components. What's the final step to actually merging all those meetings?
The really cool thing is that merging becomes so simple once you've got those connected components. All we got to do is find the earliest start time and the latest end time from among all the meetings in each component.
Oh, I see what you mean. If you've got a cluster with 3 meetings, you just grab the earliest start time from those 3 and the latest end time, and that becomes your new merged meeting.
Exactly, and we just do that for each connected component, and boom, we've got our final schedule with no overlaps. No need for all those tedious comparisons.
I gotta say, this graph approach is pretty awesome. It's like a visual puzzle, where the solution becomes clear once you connect the right pieces.
It is a great way to conceptualize the problem, especially if you're a visual person. But you might be wondering, how does this compare to the sorting approach? Which one is faster?
Yeah, that was definitely a question I had in mind. Which one is more efficient, and does it depend on how many meetings we're dealing with?
Well, the sorting approach, it tends to be faster, especially when you have a lot of meetings. It usually has what we call a time complexity of O(n) log n, which basically means that as the number of meetings that's n grows, the time it takes to sort and merge them, it grows at a much slower rate.
So sorting keeps things running smoothly, even with a super busy schedule. What about the graph approach? How does its efficiency compare?
Well, the graph approach, even though it's super intuitive visually, it can sometimes take a bit longer, especially if there are a lot of overlaps, which would make the graph really dense. It can have what we call a time complexity of, in the worst case, meaning the time it takes could really shoot up as the number of meetings grows.
Okay, so sorting sounds like it might be the winner in terms of pure speed, especially for those calendars that are just packed with meetings.
Hmm.
But you mentioned that sometimes the best tool really depends on the specific job. Are there situations where that graph approach might actually be a better choice?
Absolutely. If you're working with just a small number of meetings and you want a way to really clearly understand the overlaps visually, the graph approach can be awesome. And there are times when the connections between the intervals, like understanding which ones are related, that can be just as important as the final merged result.
I see what you mean. It's like the difference between having a neatly organized calendar and really understanding how all the tasks on that calendar are connected to each other.
Exactly. Sometimes having that visual representation is super valuable, even if it takes a little longer to figure out. But no matter which approach you pick, there are some common pitfalls and edge cases to watch out for when you're dealing with merge intervals.
Oh yeah, those tricky edge cases. Before we wrap things up, let's make sure our listeners are ready for them. What are some of the things that could really trip them up?
All right, so let's jump into those edge cases. All right, so let's jump into those edge cases. One of the classic ones is what happens if the input list of intervals, it's empty?
Ah, yes. The dreaded empty list. What happens to our fancy algorithms then?
Well, we got to make sure our algorithms are, graceful about it. We don't want them crashing or spitting out some weird results. So it's super important to check for this right at the beginning. If the input is an empty list, you just return an empty list. Simple as that.
Okay, that makes sense. Handle that empty case right away. Kind of like making sure your toolbox isn't empty before you start working on a project. Any other edge cases we should be watching out for?
Another one is what if the input list only has one interval? The algorithms need to be smart enough to know there's nothing to merge and just return that single interval.
Right, no need to overthink things when there's only one meeting on the schedule. So it's all about handling these special cases, making sure our algorithms can handle those unexpected inputs.
Exactly. It's like having a really solid error handling system in your code. You want it to be able to deal with anything unexpected and still give you meaningful results.
This has been a really insightful deep dive. We've covered the brute force approach, the elegant sorting method, and the visual power of graphs. Before we wrap up, though, I'd love to hear your thoughts on why understanding merge intervals is so important, especially for folks who are getting ready for technical interviews.
It's not just about memorizing the solution, it's about demonstrating those problem-solving skills. Interviewers, they want to see how you think critically, how you break down a problem, explore different approaches, and really analyze those trade-offs. And merge intervals. It's a fantastic problem to showcase those skills.
So it's kind of like a mini case study where you can show off how you think and work through a problem step by step.
Exactly. It's your chance to shine, to show that you're not just mindlessly coding, but you're a thoughtful engineer who can tackle those challenges strategically.
I love that perspective. It's not just about getting the right answer. It's about proving you understand the reasoning behind the code.
Exactly. Plus, interviewers often use merge intervals as a stepping stone to more complex questions. Like, they might ask you to modify the solution to handle intervals with different properties, things like weights or colors, or even apply that whole merging concept to completely different data structures.
Oh, wow. So it's like a gateway problem. It opens up a whole world of algorithmic possibilities. I gotta say, I'm feeling way more confident about tackling merge intervals now, and I hope our listeners are too. Any final words of wisdom for them as they keep learning and coding?
Don't be afraid to experiment, try different approaches, and most importantly, have fun with it.
No,
Coding is creative. The feeling you get when you solve a challenging problem, it's so rewarding.
couldn't have said it better myself. Thanks for joining me on this deep dive into the fascinating world of merge intervals. Until next time on AI.Code.Cast, happy coding, everyone.